welcome to Science with Sue and Cece.
I'm Sue.
And I'm Cece, and today we're going to be looking at chemical changes.
Yes, so we've been looking at physical changes. Now we want to have a look at what happens when there's a chemical change. So in a physical change, the substances remain the same. They don't actually become anything new. But in a chemical change, there's a chemical reaction that happens right down at the atomic level, so the atoms are reacting with one another, and you end up with new substances. Alright, so there are a few ways that you can tell when a chemical reaction has occurred, and we've got a list of 10 here. There are others, but we'll fill in these 10. So, signs that a chemical reaction has occurred. The first one, what can be produced?
A gas.
A gas can be produced. That's one. We're going to do lots of little chemical reactions shortly and observe some of these different things that can happen. Alright, secondly, what can be formed?
A precipitate.
A precipitate can be formed. Now a precipitate is just something that, a solid that falls out of solution. So sometimes when you mix two solutions together, they will react with one another and they'll produce a new substance that's actually insoluble.
Okay.
So it can't dissolve,
Yeah.
and so it comes out of solution as a solid, and that's called a precipitate.
Okay.
And we'll see one of those formed today. Right, there could be a change in
Colour.
Change in colour. Change in colour doesn't always mean a chemical reaction. If you mix two coloured paints together, you'll get a change in colour. But that's not a chemical reaction.
Yeah.
That's just physical mixing of colours that produces a new colour.
Okay.
But if a new substance is produced, it may be a different colour, and that's where you'll get the change in colour. Right, heat could be produced, which is called
Exothermic.
exothermic. So X means to put out. So heat being produced or being put out is exothermic. Or heat can be absorbed, and that's called
Endothermic.
endothermic. So if there's an endothermic reaction that actually absorbs heat, you'll feel that it actually gets cold. And we'll observe one of those today as well.
Yeah.
Light could be emitted, such as when we burn things. What do we call it when we burn things?
Combustion.
Combustion's the word to go in there. You might get a change in volume, either an increase in volume or a decrease in volume, which is going to mean a change in what?
Density.
In density. So the density, if the volume is larger, the density will increase, so long as the mass is still the same. Right, there could be a change in the melting point or the
Boiling point.
boiling point. There could be a change in the taste or the
Smell.
smell. Sometimes when a gas is released, you also get the smell of that gas as well. Right, the next one is a change in
Conductivity.
conductivity. It's not one we're going to test, that's a little bit complicated to test, so we'll leave that one. And finally, it could be a change in any of the physical characteristics. So you'll notice that many of the signs do relate to the physical properties of substances that we looked at last week.
Yeah.
So what we're going to do now is undertake a whole bunch of experiments and make some observations. What I want you to do in your table is to write down the observations in relation to those 10 things we've just looked at.
Okay.
So the things that show that a chemical reaction has occurred, all
Yeah.
of these are chemical reactions, so they will have some of those. So you can write down the observations that you make that make you think it's a chemical reaction and not a physical change.
Cool.
Alright, first one. We're going to put some Drano in some water. So if you get a beaker and pour some water in.
Yep. Enough?
Yes, that will do. About 100 mils of water.
Yep.
And this one, we want to measure the temperature of it as we do the experiment. So pop a thermometer into the water and just measure what the temperature is before we start. And then we're going to put some Drano in, and we can feel the beaker to see if it's changing temperature, but we can also read it. So if you have a thermometer, you can do the same. If not, you'll just have to rely on the touch of your fingers to feel the difference. So what is the temperature of the water, Cece?
That's gone up to 23.
23 degrees, okay. You can leave the thermometer in there
Yep.
because we want to see what happens as we add the Drano. Now,
Okay.
Drano is a fairly dangerous product. It's good for cleaning drains and it's got lots of warnings. So make sure you're wearing some safety glasses. You certainly don't want any of this in your eyes.
Okay.
And you want to keep it away from your hands as well. If you get any on your skin, make sure you go and wash it immediately. Alright, so open the Drano, and we're just going to put a teaspoon into the water and then stir it with a stirring rod. Actually, we might take the thermometer out in the first instance, just because we don't want to stir it with the thermometer.
Little shiny bits in there.
Yes.
Alright, so just grab a teaspoon.
Yeah. So don't use the spoon to stir it, just tip it in.
Okay.
And then we'll use the stirring rod. Just stir it. That's it. Good. Make sure you put the lid straight back on. Any dangerous chemicals. Now let's just stop and observe. What do you see happening already?
It's fizzing.
So bubbles are being produced. What do you
Yeah.
think those bubbles are?
I'm not sure.
Well, they're going to be some sort of gas, aren't they?
Carbon.
It might be carbon dioxide. We don't really have to know what sort of gas it is, but we know that bubbles means there's a gas being produced. Now feel the beaker and see if you can feel whether it's changing in temperature. Alright, keep stirring.
Oh, it's getting warmer.
Is it? You can feel it?
Yeah.
Alright, let's put the thermometer in so we can measure the temperature. I'll just hold that and see where it settles. Is it getting hotter?
Yeah, for sure. It's 31 now.
31 degrees Celsius. So it's gone up from 23 to 31, so we can record that. You record that now in the results table.
Okay.
Went from 23 degrees Celsius, it started at, to 31, and we observed some gas being produced.
For sure.
Excellent. For this next one, you need some red cabbage water. And we've already made some in here, but just very quickly, we'll show you how to make some yourself,
Okay.
which you'll need to do the day before you start doing these, or a few hours before, because you want it to cool down. So, you just need to take a few leaves off the outside of your red cabbage.
So that?
Yep. Then rip it up into small pieces and put it in a saucepan. Or you can cut it if you prefer. With a knife if you want to cut it.
Cool.
But you'll want a couple of leaves.
Yeah.
2 or 3 leaves. And cover it with water. Beautiful. That's plenty. Possibly a little bit less water actually.
Okay.
Just so it's covered, not so it's all floating.
Oh, alright. Yeah.
And then put a lid on.
Yep.
Put it on the stove, boil it for about, or just simmer it gently for 10 minutes. Then just leave it to cool down in the saucepan. Then strain off the liquid just in a colander and keep the liquid and throw away the cabbage leaves.
Cool.
And that's red cabbage water, which we'll use for a few different things over this year and next year. And it's not quite as red as the cabbage. What
No.
colour does it look like?
Blue.
Yeah, it is. It's a bit blue. So we're going to put some of this into a beaker.
Okay. It's about 100 mils.
Yes, about 100 mils will be good. So you can pour it without making a mess.
That's a
Tricky,
challenge.
no. Now we're just going to add a little bit of that Drano solution that we just made in the last experiment. About 5 mils, so only a little bit. Just add a little bit to start.
Okay.
Alright, okay, slow down. Get your stirring rod and just give that a stir.
Oh,
What have you noticed has happened?
it's turning green.
It is, it's turning green with a touch of yellow on the
Yeah.
edge, isn't it? Maybe pour a little bit more in.
Yeah, that is green.
There we go. And definitely yellow. I can see
On
the
the-
light
on
through
the
here. It's
rim,
quite
yeah.
yellow. Alright. So we can notice that there was a colour change from that
Blue sort of colour.
blue to greeny yellow.
Green yellow.
Yes. Alright, now I want you to get the vinegar
Yeah. Okay.
and add some vinegar to it and see what happens.
Alright.
Now, again, just a bit at a time and see what happens. And use your stirring rod just to make sure it gets poured stirred in.
Oh, it smells strong.
So we can smell the vinegar.
Yeah.
Right, add some more.
Oh, I can see a colour change there.
As it first goes in, you can see it, can you?
Yeah. So I saw this little bit of orange or red.
Okay, as it falls in. Oh, now that's changing.
Yeah, that is.
What's happened there?
Oh wow. I can't tell what colour that is. Through the bottom it looks orange.
Sort
Or
of
brown.
Yeah.
And then on the surface it looks blue.
Almost looks a bit pinky to me.
Yeah. Oh yeah, it definitely looks pinky now.
Oh, now it's, yeah, sort of a pinky purple, isn't it?
Yeah. Oh wow. That looks cool.
Alright, add a bit more. We're almost full now.
Yeah. That's starting to look like a really strong pink.
And make sure that you record your results in the table. So the main thing we saw here was a colour change, wasn't it?
Yeah,
Is there anything else from our list of signs of a chemical reaction that
Well,
we observed?
it smells a lot different. It's a much stronger smell, but that's just vinegar.
Yes, I think
Oh,
that's just
actually
the
the-
vinegar itself smelt,
Yeah.
didn't it? And we added that to it.
Yes.
So yes, it was mostly a colour change.
Yeah.
Alright, moving on. The next one, we're going to put some copper sulphate and bicarb soda together.
Okay.
But we're going to do that in a beaker with some water. So
Okay.
start with a beaker, and we're actually going to weigh ours as we do it to see if there's any change in the mass. So if
Okay.
you pour about 100 mils again of, actually we're going to sit it inside a bowl as well.
Okay.
So we start with everything that we need. Get yourself a container or just a glass is fine, but do sit it inside a bowl. There we are. Alright, so we've zeroed off the scales so that, oh, so it's bouncing around a little bit. We need to be careful we don't bump the table. Right, now we're going to put some copper sulphate in
Okay.
and stir that in to dissolve. Just a teaspoon, a scoopful from out of there. Alright. We give that a stir so it's dissolved. Right, now we do actually want to know the mass of this. So we're going to take that out, actually, and then zero it.
Okay.
So we don't need the mass of the bowl, but we want to know the mass of the beaker plus the solution. Because we don't know whether the mass might increase or whether the mass might decrease.
Okay.
Alright?
Okay.
So as we add the next thing,
So it's
we need to note.
208.7.
What's it? 208.7.
Yes.
Alright, now we're going to notice the mass when we first put a teaspoon of bicarb in.
Okay.
Here's the bicarb.
Yep.
And then we'll stir it and see what happens, make observations and note if any changes happen. You want a teaspoon?
Yeah.
There you are. Thank you. Alright, so as we put the... Are you ready?
Yeah.
As we put the teaspoon in, we're just going to check the mass when it first goes in.
Okay.
And I'm going to write that down. So that went to 216.7. And now give it a stir. And let's make some observations. What have you noticed is happening?
Well, it's kind of exploding.
Alright, there's lots and lots of
Gas.
gas
bubbles.
being produced, that's
Oh.
right.
And the mass has lowered.
It has. Oh, and it's still going down.
Yeah.
Isn't that interesting? Why do you think that's happening?
Is it because all of the liquid, the particles are sort of spreading apart, turning into gas and bubbles?
Well, a reaction is happening. It's
Yeah.
producing this gas, and the gas is disappearing into the air.
Yeah.
And the gas actually weighs something.
Yes.
It's got some mass. And so as it disappears, the mass is going down. How far has it gone down?
215.7. So it's gone down.
215.7. We've lost a whole gram.
Yeah.
A whole gram of substance has turned into gas, and that's what
Yeah.
all the bubbles were. What else have you noticed has happened?
Well, of course it has overflowed.
Well,
and
yes,
sort
that
of
was due to the
left behind
bubbles of
a-
gas.
Yeah, left behind sort of a dryness on the glass.
Yes, that's a precipitate.
Oh, okay.
What's happened is that the two chemicals have reacted together to produce an insoluble substance.
Yeah.
And that's what this is on the outside. It's actually copper carbonate. So the copper sulphate, the copper from the copper sulphate has reacted with the carbonate from the bicarbonate soda
Yep.
to produce copper carbonate, which is not soluble.
Okay.
It's also a different colour. Did you see the colour change?
Yeah, I was going to
Yeah.
say, yeah.
And just have a feel of the beaker. How does it feel?
Cold.
Cold.
Really cold.
Yes, it's also endothermic.
Okay.
And ideally, we probably should have had a thermometer in that. We might
Yeah.
do it again with a thermometer in it and just
Okay.
see what the temperature change is when that happens.
There we go. Okay, let's put the thermometer in.
Alright, so the starting temperature? What's the starting temperature, Cece?
The starting temperature is 21. Do you give it a stir?
Oh, you can probably stir it with the thermometer very gently. So pop the thermometer back in.
Oh wow, that's 15.
15 degrees Celsius, so we've just dropped 6 degrees,
6 degrees
Celsius. So that's why the outside of the beaker feels cold.
Yeah.
Because it's actually absorbed heat. It's endothermic, an endothermic reaction. For this next one, we're going to light a sparkler.
Ooh.
These are always fun, aren't they?
Yeah.
Alright, so I'll hold it, you can light it.
Okay.
And we need to look for all the different observations we can make which show us that this is a chemical reaction.
Okay. Alright, where do I light it?
Just
There?
on the end. No,
On
you
the
light
end?
it on the end. Yes.
Okay.
And make sure you don't touch the end or any of it whilst it's burning
Okay.
because it gets very hot. So, what can you observe?
It's very sparkly.
Alright.
Well, the fire's gradually going down.
Yeah, it's changing colour, isn't it? It's grey down
It
the
is,
bottom
yeah,
and it's
and
turning
it's
black
black.
as it moves down.
Yeah.
It's emitting a sound, you can hear it.
It is, yeah.
What else is it emitting?
I'm not sure.
Light!
Oh, of course.
Lots of light. Anything else?
Well,
I
it
could-
smells.
Exactly.
It's burning.
Yes, you can smell
It's-
it and you
yeah.
can see smoke.
So,
rising
yeah. Woo! Look at that smoke left behind.
Yes. So now this is black. Be careful, it will still be quite hot.
Yes.
But I'm just going to touch the very end now. And
Cool.
it's still warm. Well, no, it's actually quite hot still. So touch it carefully.
Yeah.
And that tells us that it was exothermic.
Okay.
It released heat.
Yeah.
We put a little bit of heat on in the beginning, but then the reaction that started released heat all the way down.
Yeah.
So exothermic, it emitted light, it emitted sound, there was a colour change
Yes.
from grey to black,
Smelt.
and there was a smell, and we could
And the
see
gas.
the smoke coming
Smoke,
off.
yeah.
Yes. So, and we can actually see bits of bits of charcoal
Yeah.
stuff all over the sheet. All right. Now, the next one we're going to do is to simply fry an egg.
Okay.
Alright, we'll go and see what sort of observations we can make as we fry an egg. So add a little bit of oil so that your egg doesn't stick. And once your pan is a little bit warm, which mine isn't very warm yet, we'll pop the egg in. But we'll still be able to see what happens as it begins to cook. What can you observe happening there? The egg white is turning white. Well, we call it an egg white. It was actually quite clear to begin with, but as it cooks, it definitely turns white. So that's a change in colour. We should also find a change in texture, because it was very liquid in the beginning. And when it's finished cooking, we'll have a look at how liquid it is. All the egg white's now solid, and if we give it a little flip, you'll see the egg yolk here has changed colour. It's a much lighter colour now. And in fact, the egg white has continued to change. It's actually gone brown in places, another colour change. And it's certainly quite solid. We couldn't flip it before because it was still very, very liquid. But now this is becoming quite solid. The next one is to look at a rotten egg. So we've had this egg outside for a few days. And the way to tell if your egg is rotten is to float it in water. If it's fresh or if it's still good, it's going to sink to the bottom.
Yeah.
And if it's not, it will float. So pop it in.
Oh, it's sunk.
So our egg is actually still good.
Oh, that's cool.
So we're going to have to leave it for a few more days. I don't know how long it takes to make an egg go rotten. But when it is, it changes density. It actually produces gas inside and then it will float. And then, do you know what happens when you crack open a rotten egg?
It smells.
It smells, yes. I'm not sure that I have ever actually cracked open a rotten egg.
Okay.
So we're going to keep this until it does go rotten, and you can do the same. Keep your egg until it does go rotten. Make sure it floats. If it floats, then it has changed density, which is one of the observations that shows you that it's a chemical reaction has occurred.
Yeah.
And a smell will be produced because a gas is produced inside.
Yeah.
That is very smelly. So make sure you crack it outside so you don't stink out the house, and discover what the smell of a rotten egg is like.
Okay.
Alright. This next one is called the lolly fountain. You need a 1.25 litres of fizzy drink. You can try different sorts if you want to. Get a pack of Mentos.
Okay.
Or Cool Mints apparently also work.
Yep.
And we need to open them up, but leave them in their little wrapper. Because we need them in a cylinder that we can then drop into here quite quickly.
Okay. So just leave them like that?
Well, that's going to be hard to drop in, I think.
Oh,
you actually
yeah,
need to take the outside wrapper off.
Okay.
Once you've got your Mentos ready, so that they're easy to fall out of their packet, we just need to take the lid off the fizzy drink.
Okay.
And then you just drop them all in as quickly as possible. So keep them in a row.
A row.
Yeah, don't let them fall. Yeah, that's it. So you need to keep them sort of tied up within their within their little wrapper.
Yeah.
And then tip them up so that they all fall in as quickly as possible.
Oh, I don't think they're going to fall in from the very end though. I might undo the end first. Keeping them in a row.
That's right. So you've got to keep them wrapped
That's
up.
the challenge.
We had a bit of trouble getting them back in the wrapper. So don't undo the wrapper too much. Just be ready to get them sitting over the top of the container and then loosen your wrapper and let them all fall in.
There you go. That worked!
That worked, yep. This is why we had it sitting in a bowl. So what did we observe?
Whew!
Woof, yes, so what was that?
Gas?
Gas. Yes.
Lots of gas.
Lots of gas. Lots of gas was released. So now we have a bowl of Coke, which might be somewhat flat. I don't know. But that certainly produced a good fountain.
Mm-hmm.
So most of that, the main thing we observed there was gas bubbles.
Yes.
Yes, which was just a bit of fun, really. Now, although all that gas makes it look like a chemical reaction, in fact, that was just a physical change. Because the carbon dioxide was dissolved in the Coca-Cola. When we put the Mentos inside, the surface area of the Mentos allowed that carbon dioxide to come out of solution very quickly. And that's what caused it all to overflow. So that actually wasn't a chemical reaction, that was a bit of a trick one thrown in the middle.
Okay.
Now we're going to do the whoosh bottle.
Okay.
So you need some isopropyl alcohol, which you can just pick up from the hardware store, and pour a little bit into a bottle. In fact, we might just remove the label so we can see clearly what happens.
Pour it in?
Yes.
How much?
Just enough to sort of cover the bottom. Alright, that's good. Put your lid back on so we don't spill any. And now you can put the lid on the bottle.
Okay.
And just swirl that around so it covers, actually turn it on its side, make sure it covers all the sides of the bottle. And keep turning it around so it's covered all the sides. All the way up. That's great. Give it a good shake around. And pour the excess into that container so there's not extra in there. Pour it out, tip it up, and that's it. Alright, okay, yeah, just pop the lid back on for now.
Yeah.
Alright, make sure you move any extra away because isopropyl alcohol is flammable and we're about to light a match.
Okay.
So we don't want to have it near any extra. Make sure you have some adult supervision when you do this, and in fact probably get an adult to do the match for you. Now if you take the lid off, I'm just going to put...
That's cool.
That's why it's called the whoosh bottle.
Right, okay.
So what observations did you notice?
Flames.
Write them down. Okay, light was emitted. Oh, fill the bottle. Quickly.
Oh, that's hot.
That's hot.
That
So
is.
it was exothermic.
Yes.
Heat was released. It's down here.
Down there.
Light was emitted. What else happened?
There was a sound.
There was. Sound was emitted. It went whoosh.
Yeah, there was colour, obviously, from the flame.
Yeah, there was.
It smelled.
Yes,
Smells.
you can
It's
smell it now.
burned.
Yes. This next one's called Money to Burn. If you've got some play money, Monopoly money, or any sort of play money just made out of paper, in fact it doesn't have to be money, you can just use a piece of paper.
Yeah.
Put it in a bowl and then soak it with your isopropyl alcohol.
Right.
That's alright, just pop it in there, put in a bit more alcohol,
Okay.
and then we'll use tongs to pick it up and move it around. That's it. That'll be good. And if we just pick it up, if you've got a bowl that it can sit flat in, that would be quite good. But this will work. So once it's all wet with your alcohol, then we hold it with some tongs. They can just be kitchen tongs, but I've got some chemistry ones here. And I'd like you to light a candle. Yes,
Candle.
grab the candle and light the candle.
Okay.
Again, make sure you've got adult supervision and keep the flame away from the alcohol. Just in case things get out of control, it's good to have some water nearby. So ready to dump it into if need be.
Okay.
Because we're going to light our piece of
Oh.
paper.
Okay.
We're going to put it into the flame and see what
Alright.
happens.
Oh. Oh, that was cool.
We'll put it in.
Alright.
Make sure it's wet with the isopropyl alcohol. Oh, just turn it up so the other side gets wet.
Woo! That's cool.
Isn't that great? And now it's pretty much dry.
Yeah, it is.
Why that happens is because isopropyl alcohol is partly alcohol and partly water. Now, alcohol is very flammable,
Yes.
and so it's the alcohol that burns, but water is actually very not flammable.
Yes.
Water is what you dump on a fire to put it out. So what happens is that the paper is soaked with water, and that sort of takes the heat away as the water evaporates, but the alcohol burns. So the
Okay.
heat of the burning is sort of absorbed by the water, so
Okay.
to speak, as the water evaporates. Remember, we looked at changes of state
Yeah.
and how to turn from a liquid to a gas needs energy. So all the energy from the burning turns the water into gas rather than burning the paper. And so it never actually gets hot enough to burn the paper.
No. Okay, that's cool.
So we need to write some observations. What did we observe on that one?
Alright, well again it smelled.
Yes.
It was, well, it was light.
Yes,
Fire.
light was emitted, we could see
Yeah.
that.
Exothermic?
It was, heat was released,
Yeah.
definitely. Even though it didn't burn the paper,
Yeah.
heat was released.
Yes.
And that's why the paper ended up dry, because all the water evaporated.
Okay. Yeah.
The heat went into evaporating the water.
Right.
Alright, the next one you might want to do at home or you might not. You do need to get some hydrogen peroxide for this one, which you can get from a chemist. I've actually managed to get quite a big bottle from one of my chemists. I had to ask for it specially and he got it in for me. But it means you can do it a few times. You need some yeast and some warm water. So let's blow out the candle and we'll get ready for this next one. It's elephant toothpaste. We need a 500ml bottle again. Some yeast and warm water. So we're going to put 2 teaspoons of yeast into the warm water.
Okay.
So we've got about 4 tablespoons of warm water and we'll put in 2 teaspoons of yeast. And then just stir it to dissolve. Make sure you have a nice big bowl to put your bottle into because this is another one that's likely to overflow.
Okay.
So give it a good stir. Alright, once it's all dissolved, you can just leave the spoon in there for now.
Okay.
Alright, we need to put our hydrogen peroxide into the bottle. Now this is a 100ml bottle, so we're just going to use 100 mils. If you have a bigger bottle, you can use 125 mils. So we press it down to open it. Now careful, because this is dangerous again, which is why we have our safety glasses on. We pour all of that into the bottle. So hydrogen peroxide you can use to bleach your hair. And look, you can see the fumes coming off, so
Yeah.
be careful, don't breathe it in. Now the next thing to go in there is some detergent. So give a good squirt of detergent in. Tip it right upside down so it goes in and make sure you hold the bottle well.
Is that enough?
Oh, a bit more. Because that's a very slow dribble. That's better.
There you go.
Give that a stir, make sure it dissolves.
Ooh!
It's bleached all the colour out, hasn't it?
Yeah!
So a chemical reaction has already occurred. Well, it bleached the colour out and now it's turning slightly blue.
It's blue, yeah.
Okay, next thing we need is a little bit of food colouring.
Okay.
And what can be nice is just to tip this on the side and try and get one colour down one side and the other colour down the other side.
Okay.
See how you go. So just try and let it run down the side of the bottle.
Yeah.
That's it. A couple of drops, yeah. Great.
Come on. Doesn't want to come.
There we are. That'll do.
There you go. Yeah.
Great. Nice. Now try yellow down the other side.
Okay.
Nope, that's not.
Yeah. Alright.
Alright, put the lids back on. Now the next thing to do is to pour your yeast mixture quickly into the container. So that's where we use a funnel. Hang on, now we might just take the spoon out for this.
So, and then pull out the funnel afterwards?
That's right, pour it in and then take the funnel out of the way. Pour it in quickly, take the funnel out.
Woo!
And there's our elephant toothpaste.
That's cool. Oh, look at the multiple colours.
Yeah, it's great, isn't it? It's worked well.
Wow.
Oh, that's nice.
Yeah.
I think that's the best colours we've ever had.
Yeah.
Fantastic. Oh, I like that one. Look at the beautiful arrangement we've got. Woo! In the bowl. That's okay. This is actually completely safe.
Oh, okay.
So feel it. And what do you notice about it?
Oh, it's warm.
It's very warm. This is quite a strong exothermic reaction. And whilst the chemicals that we started with were unsafe, now that the chemical reaction has occurred, they've changed into new chemicals which are perfectly safe. And you can smell the detergent.
I can, yeah.
Yes.
Smells like soap.
Yes.
And looks like
And that's
toothpaste.
all it actually smells of. And it feels like soapy.
Yeah.
Well, it is pretty much soapy water. So what did we observe with the elephant toothpaste? What were some things that showed us it was a chemical reaction?
Well, there were lots of bubbles.
Yes, lots of bubbles of gas, and that was actually oxygen gas that was being released.
Okay. It was exothermic because it's very warm.
It got very warm, yes.
And, well, it increased in size.
It did increase in volume, didn't it? So
Yes.
there's a definite change in density there. The density would have dropped a lot because the volume increased a lot. And we've actually ended up with a bit of a foam, which is
Yes.
partly because of the detergent. It makes it like that. But what we ended up with, it went from being a corrosive substance, because hydrogen peroxide is very corrosive,
Yeah.
to being a perfectly safe substance.
Okay.
Because all it did was produce water and oxygen.
Yeah.
And both of those things are safe. And the oxygen got caught up in all the suds
Yeah.
from the detergent, which is why it looked so cool. And of course the colour was just food colouring. It wasn't part of the reaction. That was just to make it look pretty.
Yeah.
Alright, and the very last one on your list is to bake a cake. We're not going to do that now. We might do that later this afternoon or later this evening. But you can go and bake your favourite cake. And basically any sort of cooking involves chemical reactions. They're chemical changes that occur.
Okay.
So if you bake a cake, what are some of the, thinking back to our list of signs of a chemical reaction, which of those do you notice? Is a
Well-
gas produced?
Not really.
Well, it is actually.
Is it?
Very often.
Oh, well, it does bubble sometimes.
Well,
When you
it
put
can.
Facebook
Yeah,
in.
no, not so much that. It's more like even baking bread. Watching the
Yeah.
bread rise, or watching the
Yeah.
cake rise, so long as you've got self-raising flour
Yeah.
or raising agent in there, then a gas is going to be produced, and that's what makes it rise.
Yeah.
So a gas is produced.
Well, there's definitely a colour change because
There is.
it can go from a dark liquid to maybe a light, like a chocolate cake can change colours.
It can indeed. Yeah.
Yeah.
Most cakes will change colour.
Yeah.
Yes.
It smells, obviously.
Yes, it smells wonderful.
Yes.
Yum.
It can grow because self-raising flour.
That's right. There's a change in volume.
Yes.
There's an increase in volume, which means there's a decrease in density.
Yeah.
Is there anything else you can think of, Cece?
Well, there was a change in state, so it went from a liquid to a solid.
The mixture was liquid, and then once it cooked, we have a solid cake. And there's definitely a change in taste. That's one time that we can taste our chemistry.
Yes.
All right. Take some time to do a symbols quiz. Make sure that you're learning your symbols as you go along, and we will see you next week.
All right.
Bye.
Bye.